Okay, welcome, gentlemen and Brian, Shelby and Genevieve, and Lori McGay, and Braulio, and Tandon, and Marlene, and Peyton, and Ali, and Antonia, and Eduardo, Alondra, Isabella, and Kevin. I think I got them all. So welcome all of you, and welcome those who are about to come. This is actually the first regular webinar. I call it week 1 webinar, whereas orientation is very different. Today is more like what you're going to see. And let me talk about what we're going to do. So the first thing I'm going to do is I'm going to share my desktop and give you kind of an agenda. Let me get it. Okay, so here's the agenda for today, and this is the plan. I'll start out with Q&A, and I'll even, I know some of the questions that you should be asking, and I'll answer some of those too, even if you don't ask. And then we're going to get into chapters 1 and 2, and I want to let you know I'm only going to do the highlights because there's a lot of details in chapters 1 and 2. None of them are very difficult. Okay, that's not where people struggle. So I'm going to give you highlights, but I'm going to expect you read the book. Okay, for chapter 1 and 2. There's nothing in it that's difficult, but you do need to read the book and maybe watch a video or two, the full-length video, for example. But I'm going to give you the main highlight, things that we're going to be using and talking about the entire course. So chapters 1 and 2 are very important. I don't want to, put them down or anything, but there's nothing that is really confusing. There's a lot of vocabulary. Vocabulary is not confusing. You just read it and see what it means and write it down and remember it or something. But nothing too confusing. It turns out, though, in terms of reality, and I don't mean this class, but reality and statistics, chapter 1 is the hardest. And chapter 1 is all about trying to come up with a survey so that your respondents represent the population. And that actually is really hard to do. Okay, and no, I'm not going to expect you to do a perfect, example of that because nobody can. In fact, there's pretty much no survey that I've ever looked at where I say, oh, that was done perfectly. I can always critique it and say this could have been done better, but that would have taken more time or more money or something like that. So I want to let you know that survey design is tough, even though understanding it in class is easy. But so I want to give you a reality check. So for our class, the test questions, that's never a problem. But when you get out of here and you have to do your own survey, you'll find out that it can be tough. So I'll give you, we're going to do an example. And I always like to bring in something real. So I have a few actually that come from, news. And especially survey companies that give the news what they need. We'll look at sampling techniques. So some thoughts on processes on collecting data in a way that represents the population as best you can, or maybe not so good. And we'll talk about it and how to critique them. And then I know this next one sounds like, isn't that what the whole class is statistics? But actually the word statistics has a specific meaning. And that is numbers that help you understand the data. And those are statistics. So we're going to talk about a bunch of different numbers that help understand the data. A lot of those numbers you already know. Things like the maximum value. I think you all understand what maximum means, okay, or minimum. I'm sure you know what the minimum is, okay? My guess is you do. Or the average. Okay, we're going to call it the mean in statistics. I think you know what average is. You probably known since 2nd grade or so. But then there's harder ones. Okay, there's standard deviation, which some of you might have heard about, maybe no, but it's a deep topic and it's really important. And that's a biggie that we'll talk about. We'll also talk about the 1st and 3rd quartile and the median and the interquartile range. And again, we'll be looking at a bunch of statistics that will help understand the data. And it turns out statistics, by the way, are for the data you collect. But what you're really doing is you're hoping to understand the entire population. So the numbers that describe the entire population are not statistics, those are parameters. So we'll talk about parameters, which are basically, they're like statistics, but for the entire population, they're things you can almost usually only guess at because all you have are statistics, and you use those to guess at parameters. And then I'll show you some charts. And these are charts you've probably seen most of before. We're not gonna do too many of, but like a histogram, I'm sure you've seen histograms and bar charts before. We'll also look at some others that you may not have seen, like the stem and leaf chart. Yeah, and by the way, if you don't have it on mute, please mute yourself unless you need to say something and ask a question, and then I'll be happy to answer. But otherwise, we're all hearing it, and that's not, it kind of gets messy. So we'll look at stem and leaf plots. That's a chart you may not have seen before. We'll look at box and whiskers plots. And I'll show you on the internet how to find them, you know, how to get them. And we'll take a look at that. I'm also, by the way, I'm going to show you how to get statistics using 2 different calculators that I have online that you need to know how to use. One is the one that you're going to use for exams, and the other one is the one you'll use for the project. And then for other things, you use whatever you feel like. But I want to kind of show you how they work. So that's the plan for today. Are there any questions that you might have about anything? And let me make sure the chat box is shown in my window. There we go. I don't see any yet. So as you're thinking, let me talk about some questions that you should be thinking about, because I've been looking at the discussion forum posts, and I want to let you know a few things to be careful of, and suggestions on how to make the discussion work. So the first one, don't forget, Thursday, both discussion assignments are due for your initial post. So that's important. Don't forget to post that. If you do it by tomorrow, I'll take a look at it and provide feedback. Okay, now with the 3 truths and 3 untruths, it's pretty hard to go wrong on that. I am looking at it just more for fun than anything, because no one's going to get them wrong. But for the survey design one, that one is the sampling technique one. That one I'm seeing a lot of people get a little confused about, which is okay, as long as make sure that you go back and look within a day, probably within a couple hours, and see if I'd said anything. If I don't say anything within a day, then that means it's good. But if I do make a comment, make sure you address that comment so you don't lose points. If you post on Thursday, I don't make comments. So I'll be checking tomorrow, and also today. I've been checking the last few days. One thing that I strongly recommend on all of the regular discussion post assignments is to get a piece of paper and pencil before you hit submit for your initial post, and answer your own post. Do it on paper and pencil. Do not show anyone else. But if you can't answer your own post, if you cannot talk about the survey design, then it's not a good post, because then your classmates aren't going to be able to do that either. Does that make sense? So if you can't find where it says and talks about survey design, and whether it's stratified sampling or random sampling or some other sampling, then it doesn't work. If you can't find the sample size, that's a bad sign, by the way. That's just a note. That's usually where often they put it in the same place. So it's always a good idea to make sure that you can answer your own question, but then don't answer your own question. I know that's tempting, but don't answer it. Just answer it on paper, but don't show anyone else. So that's a good way of making sure that it's a good post. Okay, and then if you're totally not sure, you can always email me, and I'll help you with that. Okay, so the other thing I've noticed is that I've been looking at the project discussion forums, and I'm not seeing much activity there. And I'm a little worried. You need to get partners. It's very easy. Just post, I need a partner, and then get yourself a partner. So make sure you do that. Again, it's a really easy thing to do, but you need to do it. Don't procrastinate on that one. Okay, because next webinar, next week's webinar, I'll be talking about the project already. So you need to start thinking about it. At least get a partner. Any questions before I move on? Any questions? I want to remind you, the webinars are all about interaction. Okay, they're also about me being able to bring in new stuff. So things that are current. I like to bring in news. Whereas the kind of the big long videos, there's nothing new. You're not going to see anything about COVID or any of the other things that are happening in the news, or Trump versus Biden, nothing like that. And those are the kind of things I'm going to be bringing in because, I don't know, might be interesting. At least that's what the news is caring about. Any questions? Okay, if there's no questions, let me talk about a survey example. And I have a few. So this is one example, and this is from Pew Research Center. They're a nice organization, and a lot of the news agencies will use the Pew Research Center. The problem about sometimes me going to the news agency is that often you can't find the survey technique when you go to the news agency. But this is Pew, and the article says voters' attitudes about race and gender are even more divided than in 2016. Okay, and divided by Democrat versus Republican is what they're talking about. I'm not going to read the whole article. It goes on and on and on. But now here's the question. Okay, here they are. This is a company, and they just have some staff members that are that do the survey and conduct it. And I'll let you know one of my first jobs, very strange, was I was one of the people that called people on the phone and did a survey and conducted the survey and then wrote down their answers. Okay, that was one of my first jobs. Let's see if you put the job box. Any guess on how old I was? Okay, this was at a main company. Okay, so what you're showing me is your age. Means you don't know what it was like when I was a kid. No, I was 11. It's totally against the law now to have an 11-year-old work for your company, but not in my day. That kind of stuff happened, and it was just coincidental. It's not like I knew I was going to be a statistics instructor. But the neat thing is I got like real experience on understanding how statistics works firsthand. Okay, when I was 11 years old. Okay, and nowadays I think the company people go to jail for that. But things are different. We're different then. So I did that, and I talked to people, so I really understand it. So now the question is, if you were to do a survey and you wanted to get a representative sample of the population of Democrats and the population of Republicans to find out about their attitudes about race and gender, how might you get a representative sample? Okay, first thing, there's no way you can ask everyone in America. Okay, anyone know how many people are in America? Approximately? No one knows exactly because since I asked, there's another person just born and died probably. Yeah. Yeah, it's not billion, by the way, not 300 billion, that's for sure. Yeah, it's more like 300 and something mid-million, okay? 328 million or so. Way, 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 way too many people to survey. It's not possible. So you can't survey everyone, which means you need to get a representative sample. So one thing, and I will let you know that every company and you and your projects, by the way, only adults are allowed. There's all kinds of laws about surveying children. And so in your project, you're going to do a survey, do not survey children because I don't want to go to jail. You don't want to go to jail. So first thing, most of the surveys you ever see are going to be about adults. Children are really hard legally to survey. So now we're only going to survey adults. And typically for something like this, later in this course, we'll understand why. You get a little over 1,000. Okay, sometimes 2,000, but a little over 1,000 people for a survey that is a survey about a yes/no question, for example, okay, or any kind of qualitative. So I'm going to be throwing a lot of words out at you. And so what is the word, anyone know what the word qualitative means compared to quantitative? Very important words. Yeah, qualitative means it's not a numerical value, and quantitative means it's a numerical value. Okay, So when you have a qualitative survey, if you don't have over 1,000, you usually don't have very good data. And I'll just let you know that. Okay. You don't need millions. Okay. Even though there's, 328 or something million people in the country, maybe 250 adults or something like that, 250 million adults. If you do 2,000, you actually have a really nice representative. If you have a representative sample, you can be really close to the population in terms of your numbers. So that's the good news, is that you don't need to do millions. So, but you have to have a representative sample. So there's something called bias, and bias means that the people that you surveyed are going to be more likely to go one direction than another direction. So in a yes/no question, then if the people you surveyed are more likely to say yes, okay, they think that race and gender is something we really focus on in terms of curing the issues of society, then you have a bias. If more people in your sample say yes, then all of America would say yes if you ask them all. Okay, and same thing if fewer people, either way, more or fewer. So that's called bias. So let me give you an example of bias. Okay, if I asked the very first class I ever taught as a regular instructor, how tall are you? Okay, first thing, that's quantitative, not a problem. And I tried to use that as a survey to understand how tall students are. Okay, I will tell you the average height was about 6'9". Okay, you may feel like you don't believe me, but any guess on why? Was anyone 7 feet? Yeah, most are over 7 feet. Yeah, only males, mostly males. I had mostly males, and there's a reason. Yeah, it was a UCLA basketball team. They all took my class. It was really weird, and that would be a totally biased survey. Does that make sense? To only ask basketball players how tall they are and think that that's a good representation of students in America. Okay, that would just be wrong because the average would be way high. Does that make sense? So what you want to do is you want to get an unbiased study. So if you wanted to get an unbiased study of American adults, about how they feel about race and gender, how would you do that? How would you make sure or do your best not to have bias? Any thoughts? Okay, so one idea is make sure you collect from all states. All right, so here's a problem though. You gotta be careful. Let's say you want to do a survey of 1,000 people, and there are 50 states in the United States. So 1,000 divided by 50 is 20, right? So should you ask 20 from each state? What do you think? Okay, choose different counties, but what's the problem? There's a problem with asking 20 from each state. Yeah, some states are bigger. So the idea of asking, making sure the states are represented, you'd ask a whole lot more Californians than you would Alaskans. Okay, and hopefully there's a lot more people in California than are in Alaska. Okay, even though Alaska's much bigger as a state, but not people-wise. So what you would do actually, you go online and you'd find out what proportion of American adults live in California. And then you would take that proportion, let's say I'm not exactly sure, let's say 28% of all Americans live in California. Something like that. Don't quote me on that, I'm just guessing. Then you would take 28% of 1,000, which is 280. And you would survey 280 Californians. And you would do that for every state. And then you're ensuring you have no bias based on state. Good. And Melinda, Melinda, perfect. That's called stratified sampling. So let me tell you, I'm going to go back to this guy because that's one of the biggies is stratified sampling. And that means decide on strata that are important. Okay. And as you mentioned, what state you live in might be important. Okay. How about race? This is a pretty important. Race and gender are probably important when you're asking about how you feel about race and gender issues. Don't you think? Okay. If you ask all white people, you're going to get probably a different answer than if you asked all Hispanics. Okay. Or if you ask all women, that probably might be different than if you ask all men. Might be, might not. But so different strata, and you can do multiple strata. For your project, by the way, you might just choose one. So then research how the percents of each type multiply by the sample size to establish your quota. And then go survey. Any questions on the stratified sampling idea? Okay, very much there are step-by-step processes. Okay, I will let you know that when it comes to surveying, stratified sampling or a variation of stratified sampling is the most common technique of doing sampling. Okay, Pew does it that way, Gallup does it that way, CNN, Fox, all of them, they typically do some stratified sampling. They do a variation of it called weighted sampling. It's a little more complicated than I want to get into because I don't know if you remember the name of this class. It's elementary statistics. So we're not going to do advanced statistics. If you get more advanced, then there's some extra stuff called weighted sampling, and that's a form of stratified sampling with some extra stuff. So if you see the word weighted sampling when you're reviewing an article, that's kind of like stratified. Okay,
Dr.
but I
Green?
can't get into it. Yeah, question?
So yeah, so you said go online and you find what the proportion of Americans that live in California and then you take the percentage of that, and that's the percentage that you take of Californians depending on what they take around from the country from the 1,000 students.
Yeah, so if you want to survey 1,000 people, then you take the percent in each state, multiply those percents by 1,000, right? Divide by 100 to make it work, right? And then survey that number of people in the states. So you'll end up with a whole lot more in California than Alaska, right? Nevada will have fewer also. New York will have pretty many. Does that make sense?
So yeah, sorry, I'm like all over. So you take the 1,000 students, you take the percentage, and then you divide it.
Yeah. So if it was, say it was 28%, you multiply 1,000 times 28 divided by 100. That's how you do percentage, right? Or you do 1,000 times 0.28. That's your choice.
Thank you. Divided by 100. Thank you.
Yeah, and that's because if you multiply by percent, if you multiply 1,000 by 28, you get 28,000. Well, if you're only surveying 1,000 people, you're obviously not doing 28,000 Californians, right?
Right.
So the divide by 100, that's part of percents.
Thank you.
Okay, great. Okay, so stratified sampling is one possibility. All right, I saw in the chat box, which is very interesting, someone suggested random sampling. All right, random sampling. Well, what does it mean to have a random sample? And the caution is it'll never happen in a survey of Americans. Okay, it can't happen basically. So let me give you the definition. So that means that every, I'm going to write person, but it doesn't always have to be person. You could do a sample. If you wanted to find out, say, for example, I don't know, what breed are dogs in America? Well, then you don't survey people, you survey dogs, right? You look at the dog, you write down their breed. So when I write person, that's just a placeholder, whatever you happen to be looking at. Every person has the same probability of being part of the survey. What's the problem with random sampling? Turns out random sampling, if you can do it, is the very best because there's zero bias if you have random sampling. But what's the problem? Any idea? You need a large number? Actually, you don't. The sample size we'll talk about another week. That's not today. We'll have that's 4 weeks from now or so. Okay. How would you do a random sample? In this case, how would you sample randomly Americans? So, especially how about in today's COVID times? Right? How are all sampling done basically right now? Yeah, they have to participate. You either call them or you do some web survey. Okay, now I want to ask you yes or no. Have you ever had a survey person call you on the phone and you didn't answer their survey? So yes, if you have not answered before. Okay, I'm seeing everyone saying yes. Okay, something is always yeah. So here's the deal. Already you screwed up randomness. Because if you're somebody who doesn't answer the survey, then you have a 0 probability of being part of the survey. Do you see the issue? So I'm going to write caution. This is prone to what's called voluntary response bias. And what that means is that you're going to have a type of person who doesn't answer the survey. That type of person is probably also less likely to say yes or less likely to say no. And then all of a sudden you got bias. And it's not random. So random is pretty much impossible to do with telephone surveys. So can random sampling ever happen in any kind of situation for any study? Any thoughts? Online's pretty hard because if you don't go online, then you have a 0% chance of being selected. Yeah, there we go. I like Edward's answer. If it's not a person. Okay, let me give you an example of when I did a consulting job and I was able to work with the client and the person did a random sample. And he, by the way, he was a former student and he called me up and asked if I would help him with doing a survey for him. He actually was a manufacturer of hotel towels, okay? And he wanted to study his towels. He wanted to compare with towels that he didn't make. He wanted to find out how effective, how good his towels were. Good being that if you washed them a bunch of times, do they still stay okay or do they kind of screw up in the wash? So what I had him do is I had him randomly sample towels that came off the assembly line. So he was making, I don't know, 5,000 towels a week, or I don't remember the number, something like that. So I had him sample out of picking random numbers, and computers, by the way, are very good at picking random numbers. And he just had a computer pick random numbers, and he picked that number towel off the assembly line for all the different numbers that the computer picked, and that's what he studied. And that was a perfect random sample with zero bias. Does that make sense? Easy to do. And there is no voluntary response bias with towels. Towels don't say, I'm not going to be washed. So random sampling is more often done when it's not people. It could be hours or days. You can random sample by time, and that can be done. So there's a lot of different ways of random sampling. Okay. Yeah, products work well, time works well. Customers in your business works well, as long as you don't have to talk to them. So for example, if you own a restaurant and you want to sample a bunch of customers, find out, I don't know, how much money they spend, then you can grab a random group of customers and look at their, yeah, like tipping, how much money they spend on tips or whatever, and look to see how much they tipped. Does that make sense? And that works because you don't ask them for permission. As long as you don't publish their name or anything, it's just a number. So that's important to know. So random sampling is dangerous when you're doing a survey because you can't do it. Okay, so that's one. Another is systematic sampling. And that is also done in manufacturing. So a lot of times you have an assembly line. So think about, say, car manufacturers. And maybe you need to test 100 cars to find out, you know, how their brakes work or something like that. So what you can do is take, let's say you're making 10,000 cars, maybe let's say call it 20,000 cars. Then if you take every 200th car off the assembly line, then you'll end up with 100 in your sample. And that's systematic. That's survey every nth individual. And that could be individual car, for example. Any questions on that? Okay, then there's another sampling. Okay, so when you're doing telephone sampling or internet sampling, you're almost always doing stratified. If you're doing inanimate objects, you can do random or systematic. But if you're doing in schools, in colleges, then typically you do what's called cluster sampling. What that means is you select clusters that represent the population and then survey everyone in the chosen clusters. All right, so if we're talking about colleges, what are the obvious clusters? Athletics groups, yeah, classes. Okay, so you look at the schedule of classes. Fraternities would be very biased, by the way. If you want to get a college survey and you only ask people in fraternities, one thing, you only get men, and you only get fraternity type people. Same thing with athletic groups. But you could do classes, and you could get a representative collection of classes. So you might want to do a few STEM classes, some humanities classes. Maybe you're going to do some PE classes. So you represent the college by selecting certain classes, and then you go to those classes and you survey everyone in the class. And because of our culture, if your professor asks you to do a survey in the class and hands you a survey form, you're going to answer it. So it almost never has voluntary response bias. So cluster sampling is pretty effective when you can do it. Let me give you another example of cluster sampling. Let's suppose you wanted to find out how tall the average tree is, the average, let's say, pine tree, in the Sierra Nevada mountain range. How would you do that? There's no voluntary response bias. A tree will never say, I don't want to be measured. But how would you get a good sampling, you certainly can't measure every tree in the Sierra Nevada mountain range because there's probably a billion of them. Okay, yeah, what you would do is you would get a map of the Sierra Nevadas, and maybe you would select a variety of acres in the Sierras that represent the ecology or the ecosystem. I know a few of you talked about environmental science, and you'd represent the ecosystems within the Sierra Nevadas. So you do some that were maybe a higher elevation, some that were in flat areas, some that were in very steep areas, and you would make sure it was representative. And you would maybe do, I don't know, 100 different acres like that. And then you go to those 100 different acres and measure all the trees in each of those acres. Does that make sense? And that would be cluster sampling. And it makes it so it's not that hard in terms of travel time. You can do the same thing with Americans if you have to actually talk to them in person. Of course, nowadays it's against the law because of COVID. But once COVID's over, if you have to talk to people in person, then you certainly can't just random sampling because you can be too much traveling. So then you would pick a bunch of places and then you would cluster sample in those areas. Any questions on cluster sampling? Okay, then there's a sampling you should never do if you're gonna do any kind of study you care that a lot about, and that is called convenience sampling. Okay, and convenience sampling is what it sounds like. You just survey whoever is easiest to survey, right? You ask your 50 friends the survey. What's the problem with that? Yeah, that's about the worst case of bias. Okay, you only do that if all you care about is having fun and not using the data at all. Okay, for anything that you worry about being wrong about. So that's called convenience sampling. And it's done a lot, actually. It's done poorly, like people think they can use it and they use it and it's wrong. And then it's just done for fun sometimes too. Okay, so be careful about convenience sampling. Any questions on that kind of sampling? Okay, so that's important. There's some other special techniques of sampling. And one of them is called a control study. So let me give you an example. It was an example that I personally dealt with in a terrible way. So I'm going to tell you the story. You'll probably laugh. So I was in college at UC San Diego a long time ago. Okay, how do you know what kind of sampling someone used in it, like a news agency? So that's a good question. Most of the time, not always, they use stratified sampling. And that's just from my experience. Sometimes they use convenience sampling. I don't say never trust the news, but a lot of times the news will have a link to the information on how it was done. And I like that because then I click the link and I can see how they did it. And if it's convenience sampling, I stop trusting it. If it was done by Pew Research Center, they did a pretty good job, not perfect, but pretty good job. So again, I look at it and then they talk about how it was done. Okay, and you should always look at the sample size, by the way, too. We'll talk about that later. Okay, so a control study, again, I was at UC San Diego and not having a good day, which you'll understand in a second. And I read a newspaper article, little advertisement, from the Medical Research Center at UC San Diego that said, if you have the runs, run to the medical center and be part of a study and get $100. And as you might guess, I was having a bad day. I had the runs. And I decided to be part of the study. So I went in and they gave me some medicine. And I think a day or two later, they called me up. They said, how am I feeling? It was horrible. I was still having the runs. I didn't get better at all. What I found out, because then they told me, is I was part of a control study, and I was what's called the control group. And what that means is I thought I was getting medicine and I wasn't. What I was getting was a placebo. So what a control study does is it split the sample into the control group. And you can think of that as placebo. Not sure how you spell that. I don't think that's right. Let's see. Yeah. There we go. Placebo. I love Google. It tells me how to spell things. And the treatment group. Then compare. Okay, for medicine, that's usually the only way you can really have a good study and understand it, is to do a control study. And it's usually a randomized control study because that's an easy randomization. You know, they flip a coin basically, or actually they put in a computer, and if it's heads, then you get the placebo. If it's tails, then you get the treatment group. Okay, at least I got $100. It was not worth it. But I got the money. They apologized. But it happened. Okay, and that was it. So it's used in medicine a lot. So if you're doing something when you want to find out whether or not something affects something else, you use a control study. If you don't use a control study, cause and effect can almost never be determined based on a survey. So be very careful about a survey if it's not a control study. Any questions on that? Okay, so those are a bunch of sampling techniques. I wanted to spend a lot of time on sampling techniques because it's important. Any questions on this? Yeah, usually control studies are, well, they're randomized within the group who you're surveying. The group is almost never random because that was a volunteer group, for example. You know, they post it in the news. I came up and went there. That's totally not random. But for some things, that's good enough because sometimes it doesn't matter. Okay, any questions? Okay, now what I want to do is I want to do a survey about you guys. And I'm going to show you 2 ways of doing the survey. First thing is I'm going to show you the links to calculator, and I'm going to show you how to enter data. And what I want to do is I want to do one variable statistics calculator. So we're going to look at a bunch of statistics. Now, I'm going to consider you as a convenient sample of community college students. Definitely convenient sampling because it's this class. Those who showed up, it's all statistics class, so it's very convenient sampling. So again, don't assume anything is right. It's a sample that we're interested in. And what I'm going to do is I'm going to ask you a survey. And this is something that's kind of important nowadays. People don't talk about it much, but it's a really important thing when you're looking at COVID. Okay, and the rule is you have to answer. If you feel uncomfortable, then put a number that's reasonable. But most people would feel comfortable with this. If you're not sure, guess. You know, just do an estimate. And the question is, in the last 7 days, how many people were you in a closed area within 10 feet of you? Okay, and that could be a supermarket, whatever it might be. And again, it might be guessing, you might not know exactly. Some of you were all by yourself, and it'd be, don't count yourself, by the way, could be 0. Okay, so I got 4, comma, 100, comma, keep going, type it in the chat box. We need some data here. 50, yeah, approximating is okay. Again, we're just guessing. All right, there's a lot of you, so I'm not going to get all of you because it's too much typing. And again, I just want to give you the idea of what these look like. So There we go. 150, 35, 120. One, 8. Maybe I'll get you. 124, 150. Then we had 30. 7,200. $15, $10, $22, $6. $200, $100, $20, $10, $25. $150, $120, $60. Okay, so the first thing is this is sample data because we're considering you as a representative, or maybe not a representative, but a sample from the population of students. And so it's sample data. It's biased. Okay, it's about as biased as it gets. You know, there are ways of getting less biased, but I don't have time to do that. It takes a lot more time to get rid of bias. Then all I have to do, I click sample standard deviation and hit calculate. So I tried to make this easy. Did that look easy, by the way? Yeah, you got to put commas in between the numbers. Don't forget about that. And now I want to go through the numbers. It's a crazy calculator. I don't know. I guess I'm a crazy person then, because I programmed it. I'm a computer programmer too, so I programmed this. Okay, so now take a look. The mean. Now you've heard the mean before. What is the common language for the word mean? Average. Okay. Basically add them all up and divide by the total. So that's the mean. And it is a silly number of decimals. So please don't, if you're writing a paper or whatever, don't keep that many decimal places. Okay. Is this what you use to get standard deviation for a quiz? Doing a great job in social distancing. Homework, I should say, just looking at all the things. Is that we use to get standard deviation for our quiz? Yeah, that's when you take the quiz, you can get the standard deviation that way. There are a lot of ways on the quiz, but on the exams, this is how you can do it. Okay, this is how you do it. And again, sample is different than population. So if you don't click sample, then you'll be off by a little bit. Okay, or if you don't click population, it was population. Formula is slightly different. And it's the math is too difficult to explain why. But you can trust me. I'm a mathematician, so you can trust me that it works. Okay, so there's your mean, about 68. Okay, on the homework, however many decimals it tells you, that's what you should do. If it says 4 decimals, do 4 decimals. Okay, so 68 is the average or the mean. Hopefully you all understand what minimum means. Okay, and if you don't, please ask me. Okay, and I'll just say minimum is 1, maximum is 200. Those are things you should understand. The median, 42.5. Who remembers? You get it in middle school, so it means you may not remember it anymore. Who remembers what median means? It's another word for median. Yeah, it's either the middle if it's an odd number, or if it's an even number, there's a tie for the middle, and then it's the average of the two middles. And that's what median means. Okay, any questions on that? Sometimes they call it the 50th percentile because 50% is right in the middle of between 0 and 100%. And I'm mentioning that because Q1 is the 25th percentile. Q3 is the 75th percentile. So what Q1, the median, and Q3 do is it splits the data and minimum and maximum into 4 ranges. So the lower quartile is from 1 to 15. Okay, that's the lowest quartile. The next quartile is from 15 to 42.5. The next is from 42.5 to 120. And then the high quartile is 120 to 200. And that splits it into quarters. Any questions on that? Okay. Next is, I want to mention one more thing. There is the mean, which is 68, and there's a median, which is 42.5. They're different. When do you think in the real world, can you give an example where you care more about the median than the mean? Any thoughts? House prices, because you've heard it. Why would you care about, or let me ask you, who would care more about the median than the mean for house prices? Okay, but what kind of buyers? Yeah, average buyers, although average is a bad word because most of the time you use average for mean. So let me tell you what the median gives you an idea of. And I know not all of you from Tahoe, but you can imagine we're this resort town. And one of the most expensive houses that sold last year was in Tahoe. And when I say expensive, I mean expensive in America. We have these super expensive houses. And yeah, $80 million. Okay. We get like serious houses. By the way, I don't live in one of them. They're on the beach, beautiful lake views, very different. And if you're coming to Tahoe to get an idea of what kind of a typical person in Tahoe who has a house, what are they going to live in, then the median is much better, because that 80 million is going to really change the mean. Does that make sense? Okay. All right. It was 75 million, but I was going with what you said, 80 million. But 75 million is really going to affect that mean. It's going to skew it upwards. So the mean is strongly affected by what's called outliers, whereas the median is not affected by outliers. So if you don't care much about that $75 million house, okay, if you're trying to figure out where you want to live, because that's never going to happen in your life maybe, then the median is probably better. Who cares about the mean? Okay, who cares about the mean? And I'll let you know at one point I did. Time saver to use a median versus average. I don't know, with this calculator, they just showed up. Sellers, not sellers, actually. The hint is I cared once. Buyers, nope. Now, you don't know who I was, actually. I don't think I ever told you what I used to do. Real estate agents, nope. All right, maybe I'll tell you. Politicians. Yeah. I don't think I wasn't fair because I don't think I told you I was a politician for 9 years. But politicians care a lot about the mean, because that house that costs $75 million contributes a whole lot of money to the tax base. So the politicians care about the mean because they worry about what kind of tax revenues coming in so that they can afford their government expenditures. Okay, and I was on the school board, by the way, and we had to worry about things like that. Okay, so the mean is really important if you care about that outlier, if it matters. And if you're worried about the tax revenue, the outliers matter. Okay, medicine. Outliers are really important. How come? Why are outliers important for COVID, for example? Skew the results? Let me just put it this way, because the outliers die. Okay, if you have COVID, most of the time, you'll be fine. But unfortunately, once in a while, you'll die. Okay, or a few people die. So if you look at the severity of COVID, the outlier is what everyone cares about, because death is what we worry about. We don't worry about, your typical COVID person who doesn't have any issues. Maybe is sick for a couple days. You worry about dying. Does that make sense? Yeah, real estate agents could care a little bit because they make a percent of, they only care if they can get that person who's selling the expensive house. So that is true because they get a percent of that house buying. But for COVID, the outliers are the most important because they're the ones that die. And we don't want people dying. Any questions on that idea? Okay, so I want to kind of highlight the difference between the mean and the median. Okay. Then there is the standard deviation. All right, so standard deviation is 63 about. The standard deviation gives you an idea of how spread out the numbers are. Now notice the mean was 68, the standard deviation is 63. Standard deviation is pretty big. Okay, you guys are all over the place in terms of the number of people that you have had contact with, somewhat close contact, indoor contact with in the last 7 days. Does that make sense? Because the standard deviation is high. It kind of gives you an average distance that people are from the mean. Okay, I'm going to say kind of an average distance. That's good enough for us. There is a lot of technical stuff going on in the formula, but you don't need to know the formula, but you do need to understand what the standard deviation means. Okay, and what it means is it gives you an idea of how far apart everyone is from each other, and in particular from the mean. So an outlier affects the standard deviation heavily because an average distance, so that's an average, and an outlier is very far from the mean. So that average distance is going to be increased a lot if there's an outlier. Now, I've said outliers a bunch of times, and I bet you've all heard the word outlier before. Say yes if you've heard the word outlier. Okay. All right. Here comes the hard part. What's the definition of outlier? The formal definition, mathematical. And you're going to be responsible for it. Okay, and that's a lot harder. Okay, so let me tell you what outlier is. No, it's a good guess, outlier outside the first and third quartile, but not quite. We're going to be using the standard deviation definition outlier. And what that is you take the mean and you add 2 times the standard deviation, which is about 126. And if you're over that number, you're an outlier. Okay? If you take the mean and subtract 2 times the standard deviation, and you're under that number, you're an outlier. Any questions on that idea? Again, I'm not writing this out, but it's all in the book, and you can find it. Okay, it's pretty easy math, but you have to know how to do it. So you take the mean, and you add twice the standard deviation. If you're higher than that, you're an outlier. Got it? So if I take the mean, which was about 68, and I add 126, that's twice the standard deviation. That's 126 and 68 is 194, if I did my head right. So if you're over 194, you're an outlier. So in our data, by the way, we had 1 outlier on the high side. Any questions on that? Okay, so that 200 is an outlier because it's higher than the mean plus twice the standard deviation. There are no low outliers Because if I take the mean 68 and I subtract twice the standard deviation, I don't think much. It's a negative number, and there are no negative number of people you've seen. That doesn't make sense. So it's not even possible in this case to have a low outlier. Okay, but in some situations, low outliers happen. In medicine, the outliers are the ones you care about most. Okay, so for example, if someone is an outlier when it comes to heart rate or blood pressure, and you're a doctor or a nurse, what does that mean that you need to talk to that person about? Yeah, they're unhealthy. Okay, maybe they need to take medicine. Maybe they need to run to the emergency room, depending on, how strong that outlier is. And I'm not a doctor, so I can't tell you, how much of an outlier it needs to be. But those are the ones you worry about. Whereas if they're not an outlier, they're probably fine. If they're an outlier in weight, what's the word we use? There's a word for it. Obese. Okay, if they're an outlier in weight on the high side, but about on the low side for an adult. Yeah, they're underweight and they're maybe malnourished. Okay, anorexic. So do you see in medicine, that's really important to understand outliers. Any questions on that idea? I'm going to say it, but I'm also going to type in the chat box. There's a formula called the z-score. And z is equal to the value x, so what your value you're interested in, minus the mean divided by the standard deviation. The mean, the letter we use for the mean is mu, for the population mean. The letter we use for the standard deviation for the population standard deviation is sigma, and those are Greek letters. Unfortunately, I can't show them in the chat box, but I'll let you read the book and see those letters. If it's a sample, then the letter we use is X with a bar on top called X bar, and for the mean. And if it's a sample standard deviation, we use the letter S for the sample standard deviation. Any questions on those letters? Okay. Variance, standard deviation is sigma. And it's a Greek letter. I'll let you look at the book so you can actually see a picture of it. Variance is the square of the standard deviation. I'm not going to get into it, so you don't need to get into it. But in case you're asked, it's the square of the standard deviation. IQR stands for the interquartile range. And what that is Q3 minus Q1. Sample standard deviation affects the z-score. Yes. Because it's in the formula. Sample standard deviation are very highly related. Again, because it's elementary statistics, I'll just tell you they're close to each other. They're slightly different though. So Q3 minus Q1, not Q1 minus Q3, by the way. Q3 minus Q1 is called the interquartile range, IQR. So that's the interquartile range. And what that is the middle 50%. So now let me talk about business, for example. Typically, you want to advertise to the typical person. That's the middle 50% of the population. So the IQR gives you the range, how spread out that middle 50% is. Any questions on that? Okay, then there is the sample size. Sample size in this case was 26. Hopefully you all know what that means. It's very important, by the way. And the letter we use for sample size is N. So N stands for number of people you asked. So that's sample size. So again, 26 is a small sample size, by the way. So because that's all we've got, that's all I could do. Typically, you want much bigger sample sizes. Over 30 is the biggie if you have quantitative data. This is quantitative data. Any questions on that? Okay, so the next thing I want to show you something. And this is a spreadsheet program I wrote. This is what you're going to be using for your projects. And I'm not going to retype all of them, but I'm going to type some of your answers just because I want to show you what it looks like. So for 150, 150. 35, 120. I also tried to make this easy. 1. Where was I? 8, 124, 150. That's supposed to be 150. Let me do that just a minute. 22, 6, 200, 100. 20, etc. I'm not going to do them all, but I just want to give you an idea. And this will give you everything also. In fact, you don't even have to hit enter. It just does it for you. And notice it's got the minimum, the mean, sample variance, sample standard deviation, median, maximum, Q3, and what's N, by the way? N stands for? Sample size, good. Don't forget, we're going to use that letter a lot. So that's an important letter. Okay, Q1, there's stuff that we're not going to do until later in this class. I mean, in this course. Notice there's a z-score and it says change this. Okay, if you want a z-score, you need to put in an x value to get a z-score. So let's say you want a z-score for the person with 200. Then notice it's 2.077. That's an outlier because it's higher than 2. Okay, even with this small amount of data I put in. Let's say you want a z-score for the person who just said 1. That's -1 about. Notice that that's not an outlier. So, 1 is small, but it's not that unusual. Outliers tell you, z-scores tell you how unusual something is. So if you have a z-score of 1, it's not that unusual. If you have a z-score of 3, it's very unusual. Okay, or -3. Any questions on an idea? Okay, over here, we have a histogram. Okay, and hopefully you've seen histograms before. And this is an example of a skewed right unimodal histogram. So when you think of uni, right, that's the prefix of unimodal. What's uni mean in English? It's a prefix meaning what? 1. So modal is mode. Do you remember what mode means? Again, you learned that in elementary school probably, which means you might have forgotten it. So you know what mode is? Might have learned it in middle school. I don't know. Frequency, something about frequency. Yeah, most common value. Okay, so it's the most frequent. So the most frequent, you could see there's a clear most frequent are the low numbered people. 0 to 50 is the most frequent group, and they had a frequency of 8. Do you see that? So it's not how many, but it's the most frequent. So this is unimodal because there is one bar that is clearly higher than the rest. Any questions on that? It is skewed right. Skewed right because if we take that high bar, then things tail down mostly. It's not perfect, but they somewhat tail down as you move right. So there's a right tail. Skewed left would be the mirror image of this. Symmetric would mean the mode is in the middle, and it goes down from there, or even flat from there. means left and right are the same. Okay, there's an important distribution called uniform. When I say the word uniform, what does that put in your head when you think of the word uniform? Okay, uniform is always symmetric, but it's actually more all the same, right? In the military, you wear a uniform, so you look the same. Everyone's supposed to look the same. That's how uniforms, that's the point of a uniform. So all the bars are the same height if it's uniform. Is this uniform? No, no, this is not, it's skewed right. So uniform means all the bars are the same. We give an example of what should be uniform. If I rolled a dice 1,000,000 times and I counted how many 1s, 2s, 3s, 4s, 5s, and 6s I got, then that'll probably be pretty uniform. Do you agree? Because each should be about 1/6 of the time. Okay, then there's normal. Okay, normal, let me just type in normal. Normal distribution. I think the easiest is just go to Google, then I can show you pictures. That's what I like about using this shared screen on the graph. So here's an example of what a pizza delivery times. I just randomly pick something. This is a normal curve. So is it symmetric? Yeah, this is symmetric. Left and right are exactly the same. But it's the shape is bell shaped. Sometimes they'll say that, but it's normal in our class. It's unimodal, right? It's got the high middle. It's symmetric and it tails down on the left and the right. Okay, it turns out this is the most important graph of the entire course. So get this one in your memory. Okay, just trust me, this one comes up a lot in just almost everything we do. Okay, we'll have multiple chapters just on this. So it's a good shape to know. This is normal shaped. Okay, let me type in uniform distribution. And let's show images. Notice flat. So you'll see flat, 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 and they're rectangles. So rectangle shaped, and it's just one big wide rectangle, that's it. So that's a uniform distribution. It should look flat. We'll have one chapter on that, but we're gonna spend, we're gonna have 2 chapters in that week. So it's not nearly as important normal, but it is something useful. Okay, so now you've seen some distributions. I wanna mention something. Let me go back. That guy. If I look at stem and leaf diagram, and we can do, see this 10 caret, that means 10 to the 2nd power, if this is a 2. And if I go to stats, and I go stem and leaf, then it's going to give me what's called the stem and leaf diagram. If it's a 2, that means the stems are the 100 places, and the leaves are the 10 places. And this is another way of showing or displaying data. Any questions on that? So notice we see that there are a couple that are 0, 0. That's because that's the 1 and the 8. Oh, sorry, the 1 and the 6, I guess, are 0, 0. There's some 0, 1, those are in the 10s. 0, 2 will be in the 20s. Why is it called stem and leaf? Because this hundreds is the stem and the 10s are the leaves. Okay, and someone got creative with the name. So I'm not the one that named it, but that's what they call them. So it's the stems and then the leaves from each of the stem. Any questions on that? So again, you can see the distribution. Again, we can see that it's skewed right. We can also see that the true mode is in the 20s and in the 10s if you do it rounding to the nearest 10. Okay, the stem is the hundreds place and the leaves are the tens place in this place. If we go instead, this one, make it a 1, and I go to stem and leaf, then it's going to look a lot different because we have a 1, a 4, a 6, an 8. We have a 20, a 22, a 24, 35, a 50. We have 300s, and then something way up that's past what you can even see. Okay. One nice thing about the stem and leaf is you can go back and you can look at all the individual data values. With a histogram, you only get ranges. So that's what's nice about a stem and leaf. Okay. So then there is, if I go to stats and I go box plot, this is the box plot. Okay, what this is it's a visualization of the 5-number summary. And the 5-number summary is the minimum, which was 1, the first quartile, 17, the median, which is 42.5, the third quartile, which is 105, and the maximum, which was 200. Any questions on the box plot? Okay, so this is a spreadsheet program. I want to give you a warning. For a lot of you, you're not going to be able to see the box plot or the stem and leaf, but some of your browsers are going to block it. And sorry about that. That was not my choice. It was my nightmare is what it was. It used to work, and then the browser started blocking it for security reasons. And I promise you, I will never cause a virus with any program that I write. So if it asks you, do you trust this? Say yes if it's my thing. I will not give you a virus. Okay. Sometimes it's going to ask you, should you block it or should you let it go? And again, if you let it go, you won't get a virus by me. But because of that, I also have some links to box plot, stem and leaf graphers. So in case your computer won't let it happen, there's others. There's a million that happen. But I made the spreadsheet program. I'm just curious, just total curiosity. Are any of you on the spreadsheet right now looking at it in your own computer? Aha, so yeah. Aha, I think one of you just jumped in. Okay, so you can get in. Okay. We have one of you might be a blobfish and one of you might be a rhino. I'm not sure. That's what it's given me. But you can get in, and lots of people have used this particular resource that I've made, not just our class. When you're doing your project, it is a requirement on your project to do the following. You need to copy and paste. You don't have all the data, but at least the statistics part. You need to copy and then paste it into whatever you're turning in your project with. And that could be Word or Google Docs, whatever you're going to be using. But you need to show me that you used a spreadsheet. And the main reason is if you don't use a spreadsheet, then this class doesn't transfer to a lot of universities. So this way I can tell with honesty the university that calls me up that yes, you were required to use a spreadsheet. So this is the requirement. Okay. And you can do copy and paste. You can also do like a snipping tool or something like that. Yep, it blocked it. Yeah, there are ways of getting it, but sometimes it's easier to just go to someone else's site. Sorry about that. I didn't block it on purpose. It's something Google does. I have something very important to tell you. and that is the secret word of the webinar. And that is parameter. And remember, I mentioned it, but I mentioned it pretty fast. And remember what a parameter is? Let me make this nice and big. Yeah, it's a number that's a property of the population. Okay. Copied from notes, which is fine. But your notes did not tell you it was going to be today's secret word. I'll often pick something from, but there's like dozens and dozens of words that could be your secret word. But I'll often pick something that we used in class. So parameter is the secret word. And you'll have to go to your secret word quiz. You can do it now if you want. And type that in as your answer, and you'll get full credit. So, so we've now covered sampling techniques, statistics. Remember, statistics are numbers that come from the sample. We've covered charts. I have not covered every single item in chapter 1 and 2. There's no time. It's already 7:21. I try not to make this too long as a lecture, but so you still need to, just because I didn't say it in this particular lecture doesn't mean it's not in there. It won't be on a test, for example, or your homework. But I tried to give you some of the main things, top 10 for sure. Are there any questions about anything? I'm going to unshare. Are there any questions about anything that I talked about or came up about while you were working in the class and dealing with whatever you're dealing with, homework or how to do discussion forums and all that, or discussion boards? Any questions? I'm here to, one of the big things is I want to be interactive. Okay, I try to be interactive. I try to be timely. So I'll do, unfortunately, I wish I didn't have to do this, but a lot of our examples would be about COVID. I'd be much happier if we didn't have COVID, but we do. So seems like all the statistics taken in the last couple months have been COVID statistics. Election will be the other one. The webinar is not every Tuesday. I try to alternate between Mondays and Tuesdays, but I mentioned if you don't like the time, suggest a time, I'll make it happen, as long as I don't teach another class or something else. So I think next week is Monday. I couldn't make it Monday this time because I wanted Monday to be the second chance at the webinar. Which of the formulas are essential? Okay, first thing, you don't have to memorize any formulas because remember, you get a note sheet for the test. So you don't have to know the formulas of any of these things. Z-score is the only one that's not on the calculator. Okay, although it is, so the formula for Z-score is not on the calculator. That's why I put it in the chat box. It's X minus the mean divided by the standard deviation. Don't forget to put parentheses around X minus the mean when you put in your calculator, or it'll be wrong because calculators do order of operations. Okay, just a moment because I'll be all over the place answering questions because I see questions as they go. So I think next week, if I remember right, is Monday for the webinar. But if you don't like Monday, I could do Tuesday, okay, and do it a second time. I'll be happy to do a second time. Not a problem, just make a suggestion. As I mentioned, Monday, Wednesday, Friday mornings I teach. I teach calculus. So I can't ever do Monday, Wednesday, Friday morning. Okay, but I can do lots of other times. I try not to do it late in the week. So Friday's a bad day anyway, or Thursday, because that's not enough time in between when your first thing is due, which is a discussion post. I want to make sure that you have enough time to think about it. So pretty much Monday or Tuesday, Sunday, Monday, Tuesday, Wednesday are the times I could possibly do it. But I have one time I'll always guarantee doing it, and that is what it says on the modules. Okay. And then if you want another time, make a request. and there's a good chance I'm free and I can do it. Never late at night because I sleep. So if you ask for 10 p.m., no, I'll be asleep. Okay, I'm worthless then anyway. You don't want me to do it at 10 p.m. because I won't have any brain to do. I'll be like, oh yeah, gotta wake up. Request on the Q&A form. Okay. By the way, we're in. Let me stop the recording.